So now the species below that, S sub m minus 2, the number of the population of it and how it changes is governed by this linear difference equation. Okay. So, this implies that this difference, and usually I like to use the difference calculus. They call it the difference calculus, and but for the few steps that we're going to show here, we can kind of grind it out by hand. The solution to this is going to be a quadratic in the time t. So we know it has to start off at some arbitrarily defined population plus some constant times t plus another constant times t squared. That has to satisfy this recursion here. Okay. So let us plug this expression in, or substitute this expression for this. Okay. So and let's also substitute this expression in for this. Okay. So n sub m minus 2 of t plus 1 minus n sub m minus 2 t equals alpha sub m minus 2 times n sub m minus 1 evaluated at t plus 1, which would be n sub m minus 1 at 0 plus alpha sub m minus 1 times n sub m minus t times t plus alpha, I'll expand that out, n sub m. Okay? Now we have to solve this recursion. Now to do that, and it's easy to show that n sub m minus 2 of t is quadratic in t, and if you see the pattern, that jth species down will be a polynomial of degree j in time t. Okay. I'm running out of time here, so let me just finish up with this quadratic. What you find is n, I'm going to plug this expression into here, n sub m minus, or sorry, a times t plus 1 plus b times t plus 1 squared minus a times t minus b times t squared has to equal all that on the right. This is, of course, equal to a, and this is plus b times 2t plus a b. Okay, I'm going to put that over there. So we know that a plus b has to equal this constant, okay, and the 2b has to equal the coefficient of the first power of t here. Okay. Anyway, so you get n sub m minus 2t, you plug that in, again, starts off m sub m minus 2 is 0, and I'm not going to fill in the linear term for now, let's leave that as at, plus the b term is going to be alpha sub m minus 1 times alpha sub m minus 2 times n sub m. And I think there might be a division by 2 here. So right now, for two species down on the top species, that the more the more that the top species eat, the more that this two species down, actually its population is greater, so fewer of it gets eaten. Okay, but we haven't done the complete problem where we sum up over all species, and you do the general, when you sum up all species and compute the total number eaten at a given time t, you'll find that when the top species eats more, means its proportionality constant is more species die. And if you throw in the level of sentience, that you're causing much more pain. Okay, we haven't shown all that, but we're going to get to that in the next lecture.